Yeah. Welcome back to Prescribing Hope, Azithromycin Unmasked. I'm Rittika, your host with a master's in neuroscience driven to uncover the molecular mysteries behind azithromycin's role in the COVID 19 saga. Today, we are going to look at immunomodulation unveiled, azithromycin, and host response. We explore how this antibiotic moonlight as an immune modulator, a fascinating twist in its story. Back with us is Saakshi, our immune whisperer in the microbial world. She's part scientist, part storyteller, with a knack for revealing how simple antibiotic doubles as a diplomat in the immune system fiery parliament.
Thanks, Ritika. I'm excited to dive into azithromycin's immune modulating prowess. It's like peeling back a new layer of this molecule's character.
Set the stage. Immunomodulation sounds like a powerful concept, but it's complex. Can you define what it means for a drug like azithromycin to be immunomodulatory and detail the specific immune pathways or components it targets?
Absolutely, Ritika. An immunomodulatory drug tweaks the immune system's activity, either amplifying or dampening specific responses to restore balance. For azithromycin, its immunomodulatory effects primarily involve suppressing excessive inflammation. It downregulates pro inflammatory cytokines, signaling molecules like interleukin 6 or IL-6, IL-8, and tumor necrosis factor alpha, which is also known as TNF alpha, which drive inflammation in infections or in chronic diseases. It also reduces neutrophil recruitment activation, curbing tissue damage from overzealous immune responses. At the molecular level, azithromycin inhibits transcription factors like nuclear factor kappa light chain enhancer of activated B cells and AP1, which controls cytokine gene expression. By stabilizing I kappa B, the inhibitor of nuclear factor kappa light chain enhancer of activated B cell, it prevents NF kappa B from entering the nucleus and triggering inflammatory genes. It also modulates macrophage polarization, shifting them from pro inflammatory M1 to anti inflammatory M2 phenotypes, fostering tissue repair. These effects occur at sub-antimicrobial doses, meaning azithromycin can tame inflammation even when bacteria are not the primary use, making it a very unique player among antibiotics.
Sakshi, you have unveiled azithromycin as a skilled conductor, quieting the immune system fury orchestra by dimming the cytokine brass and soothing the neutrophil drums. Its molecular finesse with NF kappa beta feels like locking a gate to keep inflammation's chaos at bay. How did scientists first stumble upon these immunomodulatory effects, and what early clinical observations hinted at azithromycin's anti inflammatory potential?
Great question, Ritika. The immunomodulatory effects were first noticed in the 1980s and the 1990s during azithromycin's use in chronic inflammatory airway disease, particularly diffuse panbronchiolitis or DPB in Japan and cystic fibrosis or CF globally. In DPB, long-term, low-dose azithromycin, example 250 milligrams thrice weekly, dramatically reduced deterioration and improved lung function even in patients without active bacterial infection. Similarly, in cystic fibrosis, patients on chronic azithromycin had fewer pulmonary flare-ups, less sputum production, and better quality of life despite stable bacterial loads. These observations puzzled researchers as the benefits extended beyond azithromycin's antibacterial action. Early studies showed reduced IL-8 and neutrophil elastase in sputum, suggesting an anti-inflammatory effect. In vitro experiments confirmed azithromycin suppressed cytokine production in airway epithelial cells and macrophages, while animal models of lung inflammation showed decreased neutrophil infiltration. These findings, published in journals like The Lancet by 2000, sparked interest in azithromycin for conditions like bronchiectasis and chronic obstructive pulmonary disease, or what we call as COPD, where inflammation, not just infection, drives pathology. It was a serendipitous discovery that broadened azithromycin's therapeutic scope.
Is it is like as if you have casted azithromycin as an unexpected hero, stepping onto the stage of chronic lung diseases to calm a stormy immune tempest. Its role in DPB and CF is like a firefighter dousing inflammatory flames, revealing a talent beyond its bacterial sword. This inflammatory potential becomes a focal point in COVID 19. Can you explain how azithromycin was hypothesized to address COVID 19's hyperinflammation and which specific immune pathways were targeted in this context?
In COVID-19, severe cases often involve a hyperinflammatory state called a cytokine storm, where cytokines, where runaway cytokines like IL-6, IL-1 beta, and TNF-alpha trigger acute respiratory disease syndrome, or ARDS, and multi-organ failure. Early in 2020, azithromycin's track record in taming inflammation in lung diseases made it a candidate to mitigate this storm. The hypothesis was that its ability to suppress IL-6 and IL-8, reduce neutrophil-driven tissue damage, and modulate macrophage activity could stabilize COVID-19 patients, particularly those with severe pneumonia. Mechanistically, azithromycin was thought to inhibit NF-kappa beta and STAT or STAT signaling pathways, which amplify cytokine production in SARS-CoV-2 infected cells. It also potentially disrupted inflammasome activation, reducing IL-1 beta release. Some in vitro studies suggested azithromycin might impair viral entry by altering lysosomal pH, offering a minor antiviral effect, but the primary focus was immune modulation. Early observational studies like those in France, combining azithromycin with hydroxychloroquine, reported reduced viral loads and hospital stays, fueling optimism. However, these were small, non-randomized studies, and the immunomodulatory hypothesis needed rigorous testing in larger trials in order to confirm its impact on COVID-19 outcomes.
As in, you have depicted azithromycin as a hopeful diplomat sent to quell COVID 19 cytokine wildfire by silencing inflammatory signals, cooling the immune battlefield. It leaps from lung diseases to a viral form like a seasoned healer facing a new plague. Clinical trials in this hypothesis, but result varied. Can you dive into the outcome of these major trials and explain why azithromycin's immunomodulatory effects didn't consistently translate to COVID 19 benefits?
The clinical trial landscape for azithromycin in COVID-19 was mixed, Rittika. Early enthusiasm from small studies gave way to sobering results from large, randomized controlled trials like Recovery, Solidarity, conducted in 2020-2021. These trials involving thousands of hospitalized COVID-19 patients found no significant reduction in mortality, hospital stay, or even mechanical ventilation with azithromycin, whether used alone or with hydroxychloroquine. For example, Recovery's azithromycin arm, where 1,600 patients showed no difference in 20-day mortality, 22% versus 21% in usual care. Several factors explain this, like timing was critical. Azithromycin's anti-inflammatory effects are most effective early in inflammation, but many trials enroll patients in later, severe stages where organ damage was advanced. Patient heterogeneity also played a very important role. Not all patients had cytokine storms, so azithromycin's benefit may have been diluted in mixed population. Dosing varied. Standard antibacterial doses, which is 500 milligram daily, might not optimize immunomodulation, unlike the low dose, long-term regimen in cystic fibrosis. Additionally, Azithromycin's weak antiviral activity did not curb SARS-CoV-2 replication significantly, and concerns about cardiac risks, QT prolongation, and resistance limited prolonged use. Smaller outpatient trials like Atomic 2 suggested modest benefits in early, mild cases, but lacked statistical power. These results highlight that immunomodulation is a delicate dance. Right drug, right patient, right time, and azithromycin's role in COVID-19 remains niche, not universal.
You framed azithromycin's trial saga as a valiant knight charging into COVID 19's chaos, only to find the battleground too vast and timing misaligned. Its subtle immune tuning, like a lute in a storm, struggled to shine amidst the late stage disease and trial complexities. Thank you, Sakshi, for illuminating this intricate dance of immunomodulation. I'm Rittika, and this is Prescribing Hope, Azithromycin Unmasked. Stay curious.